So last lesson, we learned that if give your angle, the sine, cosine, and tangent value will be a ratio, and this ratio is fixed for like a fixed value. So sine 71, that's a fixed value. So it's a numerical value, okay? And if you want to find angles, say one angle will have a corresponding ratio. So when you have a ratio, you will find the corresponding angle, okay? So if you know the ratio, you find the angle. So this exercise is basically talking about that. So if sine theta equals to k, okay, sine theta equals to k, you have a sine theta value. For example, you have your sine theta equals to a half. You know what is the ratio. And I want to find out the theta value. Okay, I want to find the theta value. So theta will equals to sine inverse of k. So I will say theta here will equals to sine inverse of a half. Okay, will equals to sine inverse of a half. So inverse is like if you have divisions, you will times it, you have add, you subtract down, so that's the reverse calculation. Okay, your sine theta equals to half, then the reverse calculation theta will equals to sine inverse a half. So we have that in the cast, okay, you can't really know the value, just look at it. So you use your cast to find the value. So sine inverse a half is still in the trig button, and you will have sine inverse. And you put a half in. Okay, control and divide give you the fraction. Okay, I like to put things in fraction form. So press Enter. Oh, that's my reading form. I need to change my setting because last time I didn't put it like default. So I need to change it every time. So degrees, going back. Okay, go up, go up, go up. Copy. Okay, 30. That's in degree form. Okay, 30 degrees. So theta will equals to 30. And it's in degree. Okay, write a degree there. Okay, so k value can only be in between -1 to 1. Okay, k value can only be in between -1 to 1. Okay, you may not really understand why you have negative values. That's more for year 11 methods course. So don't need to worry about that. But like you know that k must be less than 1. Okay, k must be less than 1. Why k must be less than 1? It's a ratio. Okay, sine theta is a ratio. The ratio is opposite over hypotenuse. Okay, opposite over hypotenuse. Okay, opposite over hypotenuse. Then opposite must be shorter than hypotenuse. Okay, opposite must be shorter than hypotenuse. Hypotenuse is the longest length in a right angle triangle. Then opposite over hypotenuse must be like, for example, 3 over 4. That number must be less than 1. Your numerator is smaller than the denominator, then the value must be less than 1. So that's why your k value must be less than 1. So don't worry about the -1 thing. That's more for year 12, year 11. But now you need to know k value must be in between 0 and 1 at least. Okay, in between 0 and 1 at least. So it must be a positive if in a right angle triangle. Okay, if in a right angle triangle, you know that's going to be greater than 0, and because the hypotenuse is longer than opposite, so it will be smaller than 1. And we'll have cosine value. Cosine will be the same. Okay, k needs to be less than 1 as well, because that is the adjacent over hypotenuse. Okay, adjacent is less than hypotenuse as well, so this number must be less than 1 as well. Okay, and for tangent, tangent equals to k, k equals theta equals to tangent inverse of k. That k can be anything, any value. Why that k can be any value? Because tangent will give you opposite over adjacent. Okay, opposite can be any number. Adjacent can be any number. It can be larger than 1, can be smaller than 1. Okay, it can be any value you like. So opposite can be 3 over 2, adjacent is 2, opposite is 3, or it can also be 4 on 3, 4 on 5. Okay, opposite is less than the adjacent. So that not necessary to be less than 1. It can be greater than 1, can be less than 1. It doesn't matter. And one thing you need to know, like, it's more get prepared for VCE is the notation. Okay, it's the notation. When I write a -1, that means 1 over a. Correct, right? That's correct. So a to the power of -1, that's 1 over a. But like sine to 1 over sine of k. Okay, this inverse here is not an indices. It's not an indices. Okay, so it's not an indices. So that means a reverse calculation. It's kind of reverse calculation. Why is a reverse calculation? Because in the normal way we calculate sine theta equals to k, and now I want to go back to calculate the theta. So just like A times B equals to C. If I want to know B, B should be C divided by A. Okay, it's the same reasoning here. Okay, so going back, how you going back to calculate the theta. So sine inverse is more a sign. Okay, it's like division, multiplication, plus, minus. It's like a sign. It's not really an indices. So that's why you don't have 1 over that. So do not confuse with that. Okay, do not confuse with that. Because what I see from like a bad answer, like when I want to calculate that. Okay, why I want to calculate that? I see one of the students doing 1 over sine a half, and that totally changed the answer. Okay, that's totally changed the answer. Because when you're going to evaluate sine a half, okay, 1 over SIN bracket 0.5, that is 100 something. Okay, that's not the angle. Like that's not the angle in the right angle triangle. But like if you go sine inverse a half, that only gives you 30 degrees. You can see that two answers are totally different. Okay, that two answers are totally different. So they are not the same thing. So that's a bad example. I'm not going to keep it here to confuse you. So just go on. Okay, we don't have that. So example 1 is find the values of theta and alpha. Okay, so we have 4 examples here. First, we have the unit for angles. Okay, we will have degree, and then the smaller will be minute, and the smallest will be second. Okay, degree, the next thing, so it's like meters, centimeters, and millimeters. Okay, we have like the units. So for degree, we have degree, minutes, and seconds. Okay, so the relationship is interesting as well. Times 60 will give you minute, minutes times 60 will give you second. Okay, 1 minute will equal to 60 seconds. That's like time, but 1 degree will equal to 60 minutes. So if I say that's 100.15 degrees, if I want to put that into degree, minute, and second, that will be 100 degree plus 0.15 degree, and you times 0.15 by 60. That's 9 minutes. The minute will be 1 dash. Okay, like 9 dash. Second will be dash dash. So that's 9 seconds. The same as your time notation. Yeah. I give it to you. 100.15 degrees equals to 100 degree and 9 minutes. Okay, just converting. So that's an example. I give you this. That's given to you. 100.15 degrees, that equals to 100 degree plus 0.15 degree. But 0.15 degree is less than 1 degree. You want to see how many minutes is that? And that equals to times 60. And that give you, 90, 9. Okay, give you 9. So it's 9 minutes. Okay, 9 minutes. Which one? Say if you have 0.04 degree. Okay, have 0.04 degree. You times that by 60 first, you have 2.4 minutes. Okay, if you times this by 60, that's 2.4 minutes. And that is 2 minutes plus 0.4 minutes. And that is 2 minutes. And 0.4 times 60 is 24. So it's 24 seconds. Okay, that's 2 minutes and 24 seconds. And that's how you convert between the 3 units. So when we talk about the size of the angle, we have degree, we have minute, and we have second. Okay. Which one? 2 means seconds and 1 dash means minute. Do you know like the timer, like you have, like we have the clock, like when you press on it, like how fast you can run, and they press it, and they will have the minute and second. Yeah, stopwatch. Yes. Oh, that's 2. No. Just example. I'm explaining. So that's 9 seconds. So 9 minutes. That's 9 minutes, and that's 24 seconds. Okay, so just some unit. Okay, just some unit. And okay, so first one, sine theta equals to 0.3907. I want to crack that into the nearest degree. Okay, nearest degree. So A theta will equals to sine inverse of 0.3907. Okay, theta will be sine inverse sine inverse 0.397. Is that 07? 07, and enter. That's 22.998 degrees, so about 23 degrees. Okay, about 23 degrees. About 23 degrees. B, tangent theta equals to a half. Theta equals to tangent inverse a half. Okay, tangent inverse a half. So tangent inverse is here. And 0.5, okay, half, 0.5. Enter. 26.565 degrees. I want to crack to 1 decimal place. That's 26.6. Convert that into minute and second. Okay, how you can convert that into minute and second? Okay, I will go to the calculator page, and that's 26 degrees. Okay, I will use that to subtract by 26. I will take off the whole number part. Okay, 26 degrees is already the whole number part, and the decimal is like that. And I can time this number by 60. I want to see how many minutes that was. Okay, that was 33.9. Okay, 33.9. So that's 26 degrees and 33.9. So it's not 34 yet, it's 33 minutes. Okay, 33 minutes. And I will subtract 33 as the whole part. Subtract the wrong thing. I'll type it wrong. Okay, I'll subtract 33 from that, and I have 0.9 minute. Okay, that's in minute, and I'll times that by 60. That's 54 seconds, 0.1 second. I'm not going to calculate the later one. So it's 54 seconds. Okay, I'll just keep subtracting the whole number part, and I can convert that into second and minute. Yeah. Sorry, what? 54?
But, you know, how, if you calculate that minute, how is it between, like, 54 seconds and
54 seconds? And the 11th? Well, let's write it like more like that way, and then that will distinguish between that. 11, you will see if it's printing, you will see quite clear. Because 26 is the whole number part, because that's already 26 degrees. And the minute is when you talk about the thing less than 1 degree, right? Like it's less than 1, like say meters and centimeters. I'll say we have 1.4 meters. The 1 meter will be the whole number part, right? There are 1 meters, and the 0.4 meters will be 40 centimeters. You only use the 0.4 to times 100 to find, because 0.4 meters is less than 1 meter, and we have a smaller unit to talk about that. So that's equals to 40. So 26.6, 26 is already the whole integer part. Okay, we already have 26 degrees, and then 0.6 degree is not enough. Oh, that's because I'm rounding that. That's already rounding. Like I rounded to 1 decimal. That's why I keep using exact values to calculate things. So if I use the rounding one, yes, it's 36 seconds. But like in the calculator, you can see that's not. Okay, in the calculator, you can see that's not. Because you have about 0.56 degrees, and that is equivalent to about 34 minutes. And that's exactly 33 minutes, and you still have 0.9 left. And 0.9 minutes, that will give you, like later here, 54 seconds. Okay. Yeah, 33, you only take the whole part if you really want to convert into degree, minute, and second. And okay. But normally question will not ask you to convert into minutes and seconds, okay? It's not it will only ask you to put in degrees. Okay, C. Cosine theta equals to root 2 over 2. Okay, theta equals to cosine inverse root 2 over 2. Okay, have a guess what's that, or it's not a guess. Anyone know that? So, cosine what will be root 2 over 2? Yeah, 45. There's no 40. 40. Yeah, there's 40, but like 40 will not be a like exact value. So, the calculator. That's like something you already know. That's a special ratio. Okay, how do I know? Because I'm teaching method, so that's why I know that. So you have root 2 over 2, 45 degrees. Okay, that's 45 degrees. You use calculator to figure it out. We will remember exact values later. Okay, not now. So there are some particular angles which will give you good numbers. Okay, 30, 45, and 60 degrees. Okay, those numbers will give you special angles. But this one is 45, and part D. Part ABC is given to you, but part D you need to set up a relationship by yourself first, and then talk about the angles. So what you have is adjacent. Okay, theta is here, alpha is here. Depends on which one you're trying to calculate. But like, if I calculate one, you will know the other one. Is that correct? If I calculate alpha, how I can know theta? Theta and alpha, you add them, that will give you 90. Okay, if you know one, you will know the other one. So let's just find one. So let's find theta. Okay, to this angle theta, you have two numerical values. One is 12 and the other one is 15. So one of the lengths is adjacent and the other length is hypotenuse. So you will have cosine relationship. Okay, cosine theta. Okay, because you want to find theta, and according to theta, the 12 is adjacent and 15 is hypotenuse. So it is 12 over 15 because cosine theta is adjacent over hypotenuse. Okay, adjacent over hypotenuse. So theta will give you cosine inverse. Okay, 12 over 15 is 4 over 5. Okay, theta equals to cosine inverse 4 over 5. I just simplify that. Or you can keep it. So cosine inverse, let's just copy that down. 4 over 5. Well, see, it's not giving you the exact value. It's not giving you the approximation values. So you press Control and Enter. That will give you 36.89. Okay, 36.9 degrees. How many decimals? Not really say. But theta equals to 36.9 degrees. Then alpha will be equals to 90 degrees minus theta. So 90 minus theta is that value. Copy that down. Enter. 53.1 degree. Okay, 53.1 degree. Where's X? That's alpha. That's not A, it's alpha. Here.
What angle is
That angle. Not really. What's the question? That's right angle, so this plus this will give you 90. Alpha plus theta will be 90. Plus another 90 is 180. Okay, so we have alpha like that, beta like that. It's not B, it's longer than B like that, and sigma is like R. Okay, so normally we use those three symbols to represent angle sigma. Do you mean how to spell sigma or how to sigma? It's not. I think it's Latin language. It's not really English, so you can't read like. I think it's Latin, so alpha, beta, and sigma. So it's those three letters. Yeah, normally we use those three to represent like angles, and theta, Hi. Okay. Example 2 will be not that straightforward. Okay, so you won't always have right angle triangle. The question will not be always there and you just figure it out for me. Like, it's not that easy. So we'll have some triangles like that. Okay, we'll have some triangles like that. So find the values of theta in each of the diagram. So we have the first diagram here. There's no right angle at all, but like we can create a right angle. So how we can make a right angle here? So this half. Okay, other way. That half. That half. Okay. So let's give a B and C. Okay, give the point ABC here. So ABC is a right angle triangle. Okay, ABC is right angle triangle, and let's put that out because we want to know the angle here, theta. And we know that's 5. What other lengths we know? Which one? CS2. Okay, because isosceles triangle and you draw a line in the middle, a vertical line, so that will give you half. Okay, separate that in half and half. So look at the theta. This one will be adjacent and that one will be hypotenuse. Okay, adjacent and hypotenuse will give you cosine. Okay, cosine theta will be adjacent, which is 2 over hypotenuse, which will be 5. Okay, let's all go for 1 decimal places. So theta will equals to cosine inverse 2 over 5. Okay, theta equals to cosine inverse 2 over 5. Let's copy that down. And that's 2. Control and enter. You have 66.4 degrees. Theta is 66.4 degrees. Okay, if you have your calculator, you can try to press it, okay? You can try to press it. A is easier. Let's have a look at it. Yeah. Oh, what? How many decimals? Oh, they will ask you if they want you to do that. So unless you just keep in degrees. Yeah. I think so. I'm not really checking the course online. I think yes. This has no. This CAS only. But you can if you like. Okay, next one. Okay, next one to find theta. Okay, can't really find theta. Theta is not the angle in the right angle triangle, but I can find this angle. Let's say that's alpha. Okay, I can find this angle. This angle will give me some value, and I can use 180 to subtract that angle to give me theta. So how I can set up a relationship between alpha and 1.73.8? Sine, cosine, tangent, which one I will use? Tan. So tangent alpha will equals to, opposite is that one, so 3.8 over adjacent, which is 1.7. So alpha will equals to tangent inverse 38 over 17. Okay, just enlarge by 10 times. So alpha, let's keep that. That's a value already. You know I can evaluate that by using CAS. So what is theta? Theta equals to 180 degrees to subtract alpha, right? 180 to subtract alpha will give me the theta. So theta will just equals to 180 degrees subtract tangent inverse 38 over 17. I keep exact values and I put all together into the CAS. Okay, I put that all together into the CAS. So I'll have 180. Where's my 1? 180 subtract tangent 38 over 17. Okay, I type that in, that's theta, and I press Control and Enter. That gives me 114.1. Okay, 114.1 degrees. Because if I type tangent inverse in first, I'll have a value. I'll copy that value down, and I'll use 180 to subtract that value. But we want to keep exact values into the last step, so you still need to do a lot of steps. So it's better to just directly type the whole line into the CAS. Okay, 114.1 degrees. Wait, which one? Like 3.8 over 1.7, you enlarge that 10 times on both top and bottom, same. It doesn't matter what you put into your CAS. Yeah, it doesn't matter. I just don't, it's more like a math teacher, like you just want to put things into the simplified form. You don't want to keep anything. Like 1.7 is not the simplified form because denominator will needs to be integer numbers. Okay, we only accept integer numbers on the denominator, so we want always trying to convert that. Next one, theta. Okay, theta is here. Okay, theta is here, and it's parallel. Can you see that's parallel? Because it's parallel, that one will be theta. Alternate angles. Okay, alternate angles. Theta will be here. Okay, so that's 3.4. So sine theta will be 1.8 over 3.4. Okay, opposite over hypotenuse. So theta will equals to sine inverse 18 over 34. That's actually 9 over 17, but let's keep like that. Do not convert that too much if you're not confident of doing that. Okay, otherwise you have a wrong answer. Or like maybe I'd rather you leave 1.8 over 3.4, like in case you make any mistakes. So sine inverse 1.8, 3.4, 31.96, so 32.0 degrees. Okay, 1 decimal place. Okay, let's write it here. That's 1 dp. Okay, 1 decimal place, so 32.0. The point 0 must be there, okay, because it's 1 decimal place. I said it. I said it at the beginning. Okay. That's example 2 and example 3. Okay, example 3. If M is the midpoint of AB, okay, M is the midpoint of AB, decide if angle ACM, okay, this angle, let's say that angle is alpha, and angle, okay, it's asking decide if ACM is exactly half of the angle ACB. Okay, ACB is this angle here. So I want to know whether ACB, half of ACB is equals to alpha. Let's say that is alpha and this angle gives me beta. And angle ACB will equals to alpha plus beta. So what I can see is if like ACM is exactly half of angle ACB, then alpha will equals to beta. Is that correct? If it's just directly cut into half, then this half and that half will be exactly the same. So alpha will be the same as beta. So that's what I want to investigate. Okay, that whole thing is what I want to investigate. So basically I have a triangle. So what this thing asks us to investigate is I have a random triangle. Okay, I have a random triangle. And from one point, okay, from one point, let's say from this point, I can go from this point A. I have a midpoint M here, and I drew AM. Okay, I connect AM from the vertex to the midpoint, and I want to know whether this line will be cut that angle into half. Okay, that's what I want to see. If I connect the midpoint, that will also like bisect my angle as well. That's the thing what I want to investigate in this question. So how I can prove or like give a counterexample that alpha and beta are not the same angle. Okay, how I can know whether alpha and beta are not the same angle? So, you know, like I can find out alpha. Okay, I can find out alpha by using the triangle ACM. Okay, in right angle triangle, in right angle triangle ACM. Tangent alpha tangent alpha will be 2 over 6. Okay, the opposite over the adjacent in this triangle. Okay, so in that triangle is opposite over adjacent is 2 over 6. So alpha equals to tangent inverse a third. Alpha equals to tangent inverse a third. So if I have tangent inverse 1 over 3, control and enter, that's about 18.43. Let's just go 18.4 degrees. 18.4 degrees. Okay, let's say I give you a function. I'm not sure if you can get it now, but I'll go through this, okay, a couple of times during the year. So say this angle, I may need this angle later, but like if I type a lot of things, this angle will, like, you need to go really high, like you can't really find it later, like, or I'm not sure where is it. So I want to install this angle, store this value, okay, as a letter. And every time I recall this letter, this angle will come out, or this number will come out. So let's just, okay, this number will be equivalent to that, right? Let's just press enter. I'll type this thing in first. And I want to store this, okay, as A. Let's say as a letter A. So I press Control VAR. VAR is the button above 9. Okay, this button above 9 here. Oh, it's not like that. We don't have that. Okay. So you have that. You don't have that thing. Okay. If you press Control VAR, you have this arrow here. And what letter you want to install it? Let's say A. You press A here. Okay. So this number store as A, and you press enter. Okay. It's done for you. So every time you press A, okay, you can see the color change. Okay, it's bound color. Okay, it's bound. So A, Control Enter, you will have this angle out. So every time you type A is equivalent as you type this number in. So let's store this value. Okay. Okay. So you put. I can't make it higher. Like. You can't, like, you just go up, and you highlight just the up button, just highlight the whole thing. And well, like, I want to install this value, store this particular value, and I'll press Control VAR. Okay, VAR is the button above 9. So you have this arrow. Okay, you call this arrow out, and yeah, VAR above 9, and then you give a letter, like whatever you want to say. But just remember that letter represents this number. Let's say the letter is A. And let's say it's B this time. Let's say it's B. And you press OK, enter, like enter. It's stored for you. So every time you press B, that will be the same number here. Okay, you may think it's not that helpful at this time, okay? But like year 11, year 12, that would be a really, really, really helpful function. Okay, so if you're year 12 math students, you do know this function, you just can't do well in your exam. Because you keep forgetting what you have before and you keep using the answers for the previous question. So this is an important function in the calculator. I think it's the most powerful one. What do you mean change it? You will have delayed, clear history. You have actions and clear A to Z. Huh? Control VAR. This button, can you see that? This button. This button. Above 9, just directly above 9. That button, Control. So let's say 2. Control VAR. Let's say I can overlap the thing as well. Let's say A, I have installed B as that number, but I press B again. Even though it's in this color, it doesn't matter. I press enter, now B is resaved as 2. So I can overlap it. So B will give me 2 now every time I press B. Okay, so come back to this question. I need to finish that. Yep. No, it's BCM is beta. I said BCM is beta. Here. Only half of it. No, part of it is M. No, okay, I have worked out alpha and I also work out beta as well. But I can't really put beta in a right angle triangle. But instead, I can work out the big angle here. Okay, I can work out the big angle here because it's in that right angle triangle. So in right angle triangle ABC, tangent of angle ACB, okay, the big angle ACB equals to opposite, which is 4, over adjacent, which is 6. Yep. Angle ACB equals to tangent inverse 2/3. Do you think tangent inverse 2/3 will equal to 2 times tangent inverse 1/3? Have a guess. Do you think that's true? Do you think tangent inverse 2/3 will equal to 2 lots of tangent inverse 1/3? It doesn't matter yes or no, okay? That's investigation. So have a think whether you think it's yes or no. And let's put that into the calculator. Okay, tangent inverse 2/3. That equals to 33.69 degrees. So what's beta equals to? Beta equals to angle ACB minus angle alpha, right? ACB minus angle alpha, that will give you beta. Therefore, beta equals to, where's ACB? ACB is just this angle here, okay? I just copy that down, okay? That angle, subtract. Okay, the previous angle is A, okay? I install alpha as A, so I just press A here. Oh, no. A, yes, A. I overlap B. B is 2. A is still that angle. And then I'll press Control and Enter. That'll give me 15.25. Okay, so 15.3. Let's say 15.3. 15.3 degrees. And you can see alpha is not equals to beta, and tangent inverse 2/3 is not 2 times of tangent inverse 1/3. Okay, so that ratio doesn't apply. So the investigation result is no. Okay, it's not going to bisect that angle. It's not going to bisect that angle. Okay, so alpha is not exactly half of the angle ACB. Okay, it's not exactly half of the angle ACB. So you need to answer the question. So the angle ACM is not half of angle ACB. Okay, example 4. Example 4. I want you to show that AB equals to that thing. Okay, I want you to show that AB equals to that. Okay, first, okay, two things you need to remember. Like show that question is very common question in missing exam as well. So show that question first. Okay, you can't use the result given to you. Okay, say AB equals to that. You will assume you don't know that at all. Okay, you need to use your own approach to work out that solution. You can't use any of the things given to you in the main question. Because if it's a show that question, you can't assume I know that already. That's not the show that question. So show that is use your own approach to figure out the answer in the question. Second is your last line needs to look exactly the same, okay, identical as what is given to you in the main question. For example, if your last line is 1 plus root 3 over 2x, you may lose mark because it does not exactly look the same, okay? I'll say look exactly the same as the question because the question asks you to show this. Why you show something else? Okay, even though they are equivalent, why? Like there's something to tell you do this and you are not following the instruction. Okay, so you need to follow exactly what the question is asking you and looks identical for the last line compared to the previous the first line. Okay, so that's the two things you need to be aware of for show that question. Okay, and we have this question here, A, B, C here. Okay, we have this question A, B, C here. And is that angle right angle triangle? Right angle? Like ACB, is that angle a right angle? No, okay. If it's not a right angle, I can't use the triangle ABC to calculate, okay? If that's a right angle, that's really easy. Sine 45 degrees equals to sine over AB, okay? That would be really easy. But first you test it's not a right angle because 45 and 30 can't make a right angle for you. So what AB equals to? Let's make an angle at D here. So AB will equals to AD plus BD. Okay, AB will equals to AD plus BD. And also you can see AD will equals to CD, right? AD 45 will give you 90. So that's an isosceles triangle. So AB also equals to CD plus BD. Okay, CD is that, BD is that. They are all in one right angle triangle. Okay, they are in one right angle triangle. So now what you're looking for is CD and BD. You're looking for CD and BD. Okay, that's the two things you're trying to work out. So you have sine 30 degrees. Okay, you have the 30 degrees, sine 30 degrees will equals to CD over BC, which is x. Okay, CD over BC, which is x. Okay, here is x. It's the hypotenuse. So CD equals to x times sine 30 degrees. Where? Okay. And sine 30. Okay, let's have a look what sine 30. So sine 30, I know it's a half. Okay, sine 30 is a half. So CD equals to a half of x. Okay, CD is a half of x. Now I will have cosine 30 degrees. Cosine 30 will equals to BD over x. Okay, BD over the hypotenuse. So what BD equals to? BD equals to x times cosine 30. BD equals to x times cosine 30. So cosine 30 equals to root 3 over 2. Root 3 over 2. Do not always press Control and Enter, okay? Try to press Enter first, always, okay, to see what value you have. If that value doesn't make sense, then press Control and Enter. Because see this question, if you directly press Control and Enter, that will give you decimals. You're not going to have the same thing as shown in the question. Okay, so you have root 3 over 2. So AB equals to CD plus BD. That's what we figured out at the beginning. So AB equals to a half x plus root 3 over 2x. Okay, 2 is the denominator. So it's x plus root 3x over 2. Okay, you add the numerator. Okay, AB equals to, let's take an x as your common factor. That's that. And can you see that's exactly looks the same already if you put the x down over there. But you can't just have that. So AB equals to root 3 plus 1 over 2 and then bracket that and put x here. Because I want to make same as the previous one. Okay. So let's check and that's exactly the same.